Hey everybody, I wanted to go over some solubility rules and remind you a little bit about solubility and what it is. So let's take a little bit of review and talk about solubility. For the video, for my previous examples, I've always kind of used sodium chloride. And so what happens when something dissolves, okay, is that you get sodium chloride, this ionic compound, and the intermolecular force between here, this is an ion-ion force, that ion-ion force that's holding those together can be overcome by water when water is present, because that's polar. Remember, water is a polar molecule. It's got two sides to it, and so the dipole looks like this. And so that means that the side with the hydrogens is positive. And so if I get enough waters floating around, what that can do is it can overcome the singular force here. So what ends up happening is that there's a force of attraction here, and other water molecules around. So then floating around in solution is the chloride ion, and the same thing can happen with the sodium ion. Okay, there's a force of attraction here between the negative side and this. This is called solvation, when water surrounds ions. So what you have is a competition of forces that causes solvation, and then eventually the ion dipole forces will win out for those compounds that are soluble. Now, what happens when we add something like silver nitrate, which again is soluble? So the assumption here is that we know that these two things are soluble, and we know that there's water floating around and stuff like that. So let's take silver, and the same thing happens with silver nitrate as happens with sodium chloride, is that it solvates. So NO3 minus, and so now these things are all floating around in solution and are surrounded by water. Now, the thing that we need to keep in mind is that they still have negative charges and positive charges, and they still may be attracted to each other. Okay, so what about sodium and chloride? Are they attracted to each other? Yes, positive and negative. But when they mix, you get sodium chloride, which we know likes to be solvated, likes to have the water around it, more than it likes to be together. Okay, so we know that we're not going to form sodium chloride. Well, what about sodium nitrate? Okay, NaNO3. Well, sodium nitrate is the same thing. Okay, that this guy would rather be solvated than anything. Okay, so this is found as ions in solution. Now, these two guys are not going to be attracted to each other. How do I know? Because opposites attract, not like charges. Like charges repel. So these guys are going to be forced away from each other in the solution. Okay, and so that really gives us all the options for these guys without silver. Now, same thing with silver. Silver is not going to be attracted to sodium because that forms, because they're the like charges, they're going to repel each other in that solution. And the thing to think about is that these ions are floating around in the solution. You know, they're in the solution, and they're able to act independent from each other. They're able to move kind of just as particles through the solution. And so this guy acts independent of everything else, of the chlorine that he originally came in, and he's going to act, oh, hey, here's a nitrate. Nah, I'd rather be with water. I'm going to stay away from the silver. Okay, those things are happening. Okay, so, and then silver with the nitrate, That gets us back to the original compound, silver nitrate, which we know would rather be solvated or would rather be in solution. But then we get to this guy. Okay, this guy is a silver chloride. And silver chloride, actually, these two things, they come together, they're attracted to each other, and this thing actually becomes a solid. So as these guys float around in solution, these things come together and they become a solid and sink to the bottom of the solution. And this is one of what we call a driving force of the reaction, is that this reaction is going to want to occur because this ion floating around and this ion floating around, when they get together, they are going to stay together, stick together, because they would rather be together than solvated. Okay, and so these guys become solid. Silver chloride becomes a solid. Now, I get it. Your questions are going to be like, hey, well, how do you know? What does what and what doesn't do what, and how does it all react? Well, it turns out that there's a list of solubility rules. Okay, and so I'm going to actually draw a little list here with solubility rules, or a little line here. And I'm going to say, I think it's really important that we know this. Okay, I'm going to put a 1 here, that we kind of commit that all nitrates, no matter what, are soluble, and all acetates are soluble. This is acetate ion, are soluble no matter what. Commit those to memory. And I think it's important to commit this to memory. Okay, so if I bring up my periodic table, it's kind of funny because if we look at what that is that's soluble there, okay, the things that are soluble are the alkali metals plus NH4+. So those guys are the soluble ions. Okay, and that's what we're trying to say here, is that it's the alkali metals, so lithium, sodium, potassium, rubidium, cesium. We don't use francium in compounds very much, so you can know that one. And then ammonia. So that comprises the list of everything that is going to always be soluble. So that's how I know sodium chloride is going to be soluble, because sodium is an alkali metal. Okay, Na falls under the alkali metals. Okay, I'll put a 1 next to this one as well. Okay, now these guys here, chloride, bromide, iodide, and sulfate, I would kind of put this as number 2, as solubility rules to have memorized, because I think that most of the time it's silver, lead, and mercury are the exceptions. So all chlorides are soluble, all chlorides are soluble except for silver, lead, and mercury. Okay, and so then these guys then become like the 3. Like, you may have to look those up, or you can probably look those up. So these are the solubility rules. If they're soluble, if they're on this list up here with these exceptions, if it's this, they're going to split apart in solution. They're going to become solvated. If they're down here, or they're on this list of exceptions, that means they are going to be solids. They're not going to be solvated. They're going to be found in the compound as a solid. So there's the solubility rules, and reviews some of the chemistry behind forming solutions. I hope you have a great day.